Time for the code demo. We want to first create the constant n and k. So there are 8 days and 3 products. Let's use lowercase. Let's start off with the input like that. And we want to create the total to the array. We have 2 to the power of 3 rows and 8 columns. Right? Before we do anything else, first thing should obviously want to print this out first. So here's the debug, how many rows we have and how many columns we have, and we're gonna just print of I and j like that. So right now, as you can see, our table is pretty messy because of all the in-memory debris, but we'll be populating this so that it matches with our own paper numbers. So before we start the recurrence relation, we want to first populate the default values. So top row has to be 0 because it represents the empty set. So I'm going to fill the first row with 0. You can see that we have emptied out the first row right over here. And then we want to put the first column with infinity. So for every row, first column is going to be infinity. And I want infinities to be printed a little bit more nicely. So I'll say that if total of ij is infinity, I will simply print the dash instead. So this will print a dash, otherwise that. I don't think we need these, so let me just go with that. I think we need this. All right, so what you can see, we have 0 top row and we have infinity left column, and then we can kind of try calculating the rest of them. So this is the real meaty part of this code. I'm gonna call it solve. So what we want to do is to first go to every product and then populate its first day pricing so that we have 6, 8, and 5. And then we can start with day 1 through day n. Recalculating or calculating total of every set D. So what we need is to go over every possible sets. So for every set, we want to first set that SD to be the previous day. So if you don't make a purchase, now if you are making a purchase, you want to do that for every product within S. So every product X within S. So S and the bit representing the X needs to both be there. So I'm gonna do N. So S must include X. If it does, then total of S and D is simply total the same set excluding X from the previous day plus the price of X on day D. Now, obviously, this doesn't work. This doesn't mean anything. So we're going to have to exclude the X bit from S. And we can do that by taking the exclusive OR and doing 1 shift X, right? So we're going to take that. Obviously, we want to update total SD to this only if this makes it smaller. So we'll say min of total SD and that's it. So you can see that the first 2, 3 rows will match what the numbers that we have on paper, and also we have the total answer of 5. Finally, let's talk about the complexity. Looking at this table, we have to populate the table. So it's n by 2 to the power of k, right? N by 2 to the power of k. For each cell, you also have to look at single bit within that combination. So that will add an extra k. So the total complexity will be O n times 2 to the power of k times k. So we should definitely be looking at a substantially small k value, 32 for an integer and 64 for a long integer. And one of the prime examples of such things will be like an alphabet, because they're only 26 characters, or some list of products who is limited to about 30 to 50 products.